Segment relationships in circles. Our objectives are to find the lengths of the segments formed by lines that intersect circles, as well as use the lengths of segments in circles to solve problems. Who uses this? Archaeologists use facts about segments in circles to help them understand ancient objects. Let's look at some vocabulary first. A secant segment is a segment of a secant with at least one endpoint on the circle. External secant segment is a secant segment that lies in the exterior of the circle with at least one endpoint on the circle. So if we look at the diagram below, PM, NM, KM, and JM are secant segments of circle Q. NM and JM are external secant segments. A tangent segment is a segment of a tangent with one endpoint on the circle. For example, AB and AC are tangent segments. Let's look at a theorem. If two chords intersect in the interior of a circle, then the products of the lengths of the segments of the chords are equal. So, AE times BE equals CE times ED. Let's try an example. Find the value of x and the length of each chord. Well, we take our two smaller pieces and we multiply them together, and then we do the same with the other chord. So we have 6 times 4 equals 8 times x. Well, 6 times 4 is 24. That equals our 8x. Doesn't look like much of an x there. There we go. And then we divide by 8 on both sides. So 24 divided by 8 is 3. Well, there's our x value. Now we need to find the length of each chord. So PR is 6 plus 4, which gives us 10. And ST is going to be 8 plus our 3, which will give us 11. Let's look at a real-world application. Archaeologists discovered a fragment of an ancient disk. To calculate its original diameter, they drew a chord AB and its perpendicular bisector, PQ, to find the disk's diameter. Well, since PQ is the perpendicular bisector of a chord, PR is the diameter of the disk. Following our same formula, we would have AQ times QB equals PQ times QR. So our little pieces multiplied together equals our little pieces multiplied together. So let's substitute our values in. So we have 5 times 5 equals 3 times the part that you do not know. So 5 times 5 is 25. Then we're going to divide both sides by 3. And when we do so, we end up with QR equals 8 1/3. So 3 plus 8 1/3 gives us 11 1/3 inches. So the diameter of our disk is 11 1/3. Let's look at another theorem. Secant product theorem. Well, if two secants intersect in the exterior of a circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. So whole times outside equals whole times outside. So the whole thing, which would be AB plus BE, so AE altogether, times whatever's outside, so BE, equals the whole, which would be CD plus DE, so the whole thing for CE, times whatever's outside, so DE. Let's try an example. Find the value of x and the length of each secant segment. Okay, so we have our whole, which is RT, times whatever's outside, which is RS, equals RQ times the outside, which is RP. Well, RT, its total is 10. So we have 10 times 4 equals, we don't know what this x is, so just 5 plus x times 5. Well, 10 times 4 is 40, and then we have to distribute this 5, so we'll have 5x plus 25. Subtract 25 from both sides, and then divide by 5. Once you have what x is, that's one of the pieces, now we just need to plug it in. So RT is going to be 10, and PQ will be 8. Let's look at another theorem. The secant-tangent product theorem. If a secant and a tangent intersect in the exterior of a circle, then the product of the lengths of the secant segment and its external segment equals the length of the tangent segment squared. That was kind of wordy, so let's look at it like this. So similar to our last one where we had our whole times the little piece that was outside, that's going to be for our secant. Now our tangent is just outside, so that one is going to just be squared. So in this case we have our total AC times our outside, which is BC, equals DC squared. Let's try an example. Find the value of x. Well, we know that we have to have our whole, so in this case our whole is 5 plus 4, which is 9, times whatever our outside is, so this RQ, equals our tangent, so we have PQ, and then we want to square that, so x squared. And 9 times 4 is 36, which equals x squared, so x equals the square root of 36, which is 6. And that concludes our lesson on segment relationships in circles.